Hello students, welcome to the class. So our next topic is motion in a straight line. So this motion in a straight line. In this chapter, we will be covering what do you mean by straight line motion, what do you mean by motion, types of motion. Okay, the terms related with the motion. So when we can say that the body is moving fast, when we can say that the body is moving slow, what are the terms we can use here? These all concepts we will be discussing in this chapter. And here the main point is the equation of motion we will be discussing. So equation of motion is nothing but it will give the relation between the initial velocity, final velocity, distance covered by the body and acceleration of the body, right? So let us start with the class. See here, in our day-to-day observation, we observe many phenomena, right? We observe many phenomena, we observe many bodies. So here, so we see that many objects around us, some are in rest, some are in motion, right? So if you observe the trees, houses, stones, these are all we feel that they are at rest. Okay, we can see the flying birds, moving animals, cars, vehicles, right? So we see that they are in motion. So here the study of this motion of the bodies is very, very important. So this motion, how we can describe that we need to see here. This motion can be defined as, see here, in physics we have many branches like thermodynamics, current electricity, electrodynamics, nuclear physics. So we have many branches. In that there is a branch which purely deals with this motion of a body. Okay, so the branch is called as mechanics. It is a branch of physics which deals with the study of motion of a physical bodies. So mechanics is nothing but it is a branch of physics which deals with the study of motion of a bodies. Okay, so this mechanics again we can classify. So the mechanics can be classified into three types here, that is statics, kinematics and dynamics. So what do you mean by statics, dynamics and kinematics? Let us see. The first one, statics. Statics means what here? It is a branch of the mechanics which deals with the study of physical bodies at rest. So in mechanics, we have three branches, statics, kinematics and dynamics. So in that, statics deals with, so as we know that around us, the bodies are at rest, the bodies are in motion, right? We observe so many phenomena. In that, when the bodies are at rest, the properties related to that, what we do studies that we study under the heading called as statistics. Then next we have kinematics. Kinematics is what? It is a branch of mechanics which deals with study of motion of physical bodies without taking into account the factors which causes motion. So what do you mean by this? See here, as we know that motion is nothing but what? Motion is nothing but when the body change its position. See here, for example, on a table or anything which is kept on the floor here, unless and until you apply the force, unless and until we apply the force, the bodies will not move here, the bodies will not move. So this is what, when the body is changing its position, this is called as motion. The body is changing its position, it is called as motion. Okay, if the bodies are not changing its position with respect to time and temperature, with respect to time and surrounding, then it is called as the bodies are at rest. Okay, so as we know that, what is the cause for the motion here? Force applied on a body is the cause for the motion. Means when you apply the force, then the body will start moving, right? Therefore, we say that the cause for motion is what? Force applied on a body. Here, kinematics is what? It is a branch of mechanics which deals with motion. Static deals with rest, kinematics deals with motion, but here we don't study what is the cause for the motion. Means here, as the force is responsible, we don't study that which force is there so that the body is moving. We don't study those points here, okay? We directly go for only the motion concept. We don't study which force is responsible, whether it is a gravitational force, nuclear force, which force is necessary to change the position. That all we don't study here. So that is what kinematics. Then what is the difference between kinematics and dynamics now? The dynamics also a branch of mechanics which deals with the study of motion only. But here we study that what is the cause for the motion. Okay, kinematics, we don't study the cause. In dynamics, we study the cause, means whether the nuclear force is applying, gravitational force is applying, or which other force is applying on a body. Okay, so this is what do you mean by mechanics? What are the types of mechanics? Then next. So here we are going to define the proper definition of, that is rest and motion. Rest and motion. Okay. So as I told you, rest is nothing but what? When an object is said to be at rest, which does not change its position with respect to the time. So we can consider that with respect to time and temperature, with respect to time and the surrounding, we can consider it as time and surrounding. Okay. Then that is called as what? It is called as the body is at rest. The body is at rest. Next, here we have an example, that is a whiteboard in the classroom is at rest with respect to the of the classroom. Means here if you observe any object, we need to observe it with respect to that frame of reference. So that is called as what? That is nothing but here the object. You can consider the whiteboard in the classroom. That is example for the rest position. With respect to the classroom, it is at rest. Then next is next definition. What do you mean by motion? So here motion is nothing but an object is said to be in motion if it changes its position with respect to the surrounding. So rest is what? When the object is not changing its position with respect to surrounding and time, it is called as rest. When it is changing its position, then it is said to be it is in a motion. So here we are seeing that example is when we walk, run, ride a bike, we are in a motion with respect to the ground. So this is what the example for motion of a body. Right. Next. That is, see, whenever we are studying this motion and rest, we need to study with respect to that given particular frame of reference, I said. So what do you mean by frame of reference here, students? See, that is, so for example, if I want to define any particular object, which whether it is in motion or it is in a rest position, we need this frame of reference concept. So what is frame of reference here? So frame of reference is nothing but here, this is called as it is a fixed point or a fixed position. This is nothing but fixed point or fixed place with respect to the position and velocity, acceleration, etc. of a body or an object is measured is known as what? Frame of reference. Means here, for example, if I want to define, suppose if you are traveling from your home to your college, you are traveling from your home to college. So here, whatever the motion you are defining with respect to this frame of reference. Suppose if I am defining the vehicle is moving in a straight line, I'll take it one coordinate as x, one coordinate as y. So here, when the object is traveling in a straight line, we need to define it with respect to some point here. So with respect to some point or with respect to some distance places. So this fixed point, it may be anything. Suppose if I say you are walking, so if you are walking from one point to other point, here the reference frame is what? Suppose you are traveling, going from your home to ground. So this is the reference frame. This is what the fixed point or the fixed places to define the motion of a body, its velocity, acceleration, displacement, and all. That term is called as what? Frame of reference. It is called as frame of reference. So this frame of reference will change here. For example, if you are observing the planetary motion, the sun planetary motion from the earth. So from the earth, you are observing the planetary motion here. So your earth is what? Your earth is frame of reference. Your earth is the frame of reference here. Getting? So suppose if a person is in a space, if the person is in a space, he is observing us from the space. Then frame of reference is what here? Space. So this is how we take the frame of reference, means the observation point it is. Okay. So here we define there are three types of frame of references. There are three types of frame of references. One is Cartesian frame of reference. One is Cartesian frame of reference. And one more is spherical frame of reference. Then third one is cylindrical frame of reference. So we have three types of frame of references: Cartesian, spherical, and cylindrical coordinate, that is a cylindrical frame of reference. Okay, so here in all the term we just go, that is the noting the frame of reference is different. So in Cartesian we take it as XYZ, in spherical polar we take it as R and theta. So like that it will vary. Okay, so we don't get any questions based on frame of reference, but you should have an idea what you mean by frame of reference. Its types, it is not there in the given syllabus. Okay. Then next. So here we discussed what is mechanics, types of mechanics. What do you mean by motion? What do you mean by rest? Examples. And here frame of reference, which is important for defining the motion. Okay. Next, so we have next concept called as types of motion. So what are the types of motion? Here, motion we are dividing it into three types. Motion we are dividing it into three types. So the first one is one-dimensional motion. So there are three types are there: one-dimensional, two-dimensional, and three-dimensional motion. So first one-dimensional motion. What is one-dimensional motion? See, if only one out of the three coordinates specifying the position of the object changes with respect to time, then the motion is known as one-dimensional motion. As I told you, so in a frame of reference, there are three types are there. In that Cartesian coordinate we will take into account in this chapter. So the Cartesian coordinate systems are having the coordinates x, y, z. So all the three coordinates are perpendicular to each other. All the three coordinates are perpendicular to each other like this. So this is what x, y, z, three coordinates. So see here, what is one-dimensional motion? If only one out of three coordinates specifying the position of object changes with respect to time, then the motion is said to be one-dimensional. Means here, suppose if you are specifying any motion of the body, here we are taking into account only any one coordinate. Either it may be x, either it may be y, or it may be z coordinate. Means the example we can take, the body is traveling in a straight line path. Okay, or you can take a train example, train moving along a straight track. So here you can see when you are studying this, either you can study along x, suppose the motion is along like this, then only y coordinate. If it is like this, only z coordinate. Only one coordinate we study for the motion here. So that is called as what? One-dimensional motion. If any one of the three coordinate is changing with respect to time, then it is known as one-dimensional motion. So examples are, that is the train traveling in a straight track, then a freely falling body, the motion of a freely falling body. So motion of a freely falling body means, suppose any object which is thrown up. So when it is falling freely, here also only any one coordinate we will study. So these are what the example for one-dimensional motion. Out of three, any one we are using, that is called as one-dimensional motion. Then next we have two-dimensional motion. If only two out of three coordinates specifying the position of the object change with respect to time, then the motion is known as two-dimensional motion. Here, what happens? Two coordinates will change. Example, the motion of planets around the sun, the car moving along a zigzag path on a level road. So these are what example for two-dimensional motion. Three-dimensional motion. So what do you mean by three-dimensional motion? If all the three coordinates specifying the position of the object, it changes with respect to time, then the motion is known as what? Three-dimensional motion. So the example is the motion of aeroplane in a space, the kite flying a windy day. So here means the motion which is a free type motion, like the motion of aeroplane, the motion of a bird or the bird flying. These are all what? Example for three-dimensional motion. Means when you are describing its motion, you need to specify all the three coordinates, right? So that is what three-dimensional motion. Then the next concept is, here we say that rest and motion are relative. See here, how we can say that motion and rest are relative terms. That is, see here students, as we know that when we are defining motion and rest, we define it with respect to the surrounding. We define it with respect to what? Surrounding here, right? So when you are observing, suppose if you imagine a students are sitting in a classroom and the teacher is taking class. So here, with respect to the students, the teacher is at rest, and with respect to the teacher, students are at rest, right? But here, with respect to the earth, as we know that earth is in motion, or you can see that the observer is observing from the space. So the observer who is observing from the space, for him, the teacher and the students are in motion. Why? Because here the earth is rotating, along with the earth, even we are moving. Therefore, the person who is watching us out of the frame, for him, it looks like we are in a motion. Okay, but for teacher and student, they were at rest. So here what happens, that is, therefore, we can say that rest and motion are what? Relative terms. See here, rest and motion depends upon the observer. It depends upon what? Observer. The object in one situation may be at rest, whereas the object in another situation may be in motion. Right? So here you can take one more example. When you are sitting in a bus or a train, when you are moving, you can see the outside objects like trees, other houses and buildings. You feel that they are in motion. As you are in motion, you feel that they are also in motion, but actually they were at rest. Therefore, here we can say the rest and motion are relative terms. A driver of a moving car is in motion with respect to an observer standing on the ground, whereas the same driver is at rest with respect to the man in the passenger's seat. So, simple example, right? So, for the observer inside the vehicle, both are at rest, but the observer out of the vehicle, for them it is in motion. So this is how we can say that rest and motion are relative terms. Similarly, not only rest and motion, darkness and brightness are also relative terms. Why? Because the absence of darkness, we take it as brightness, and the absence of brightness is nothing but darkness here. So in the same way, brightness or the light and the darkness is also example for what? Relative terms. Relative terms. Okay, then next. So in this chapter, we come across the term called as point object, point mass. These terms we use here. So what do you mean by that? An object can be considered as a point mass object if during the course of motion, it covers distances much greater than its own size. So what do you mean by that? An object which can be considered as a point mass if during the course of motion if it covers distances much greater than its own size, then it is called as what? Point mass. Suppose if you consider very small object here, this object, when this object is there, this object when it is moving, the object when it is moving here, it covers larger distance compared to its size, then it is called as what? Point mass. Then it is called as point mass. Okay. Suppose if you are studying the motion of the earth, so motion of the earth, so whatever the motion of the earth you are studying from the out of the frame of the reference, that time we consider the body as what? We consider the body as point mass. That is the object as point mass, right? So this is how we can define it. That is point mass or a point object. Next. What do you mean by rectilinear motion? So here motion can be described in many terms. So here one we have, that is motion, rectilinear motion. What do you mean by rectilinear motion? Rectilinear motion is nothing but it is a straight line motion. When the objects are traveling along a straight line path, then it is called as what? Rectilinear motion. Okay. See here, when the motion is said to be rectilinear, study of objects along a straight line path. Either it may travel in any of the direction, either x-axis, y-axis, z-axis. So if the motion is along a straight line, then it is called as rectilinear motion. So we say sometimes as rectilinear motion, sometimes we take it as linear motion also. So both are same, rectilinear motion and linear motion. Right? The next concept. So here we are going to define the terms related to the motion. The first definition we are discussing, that is position. So what do you mean by position? See, position of an object is always defined with respect to some reference point, which we generally refer to as origin. So reference position is nothing but, for example, if you are traveling from your home to your college, here how you measure the distance between home to school college means, here what you do, you will take a reference point. Suppose if you want to say you moved 5 kilometers, so with respect to what you moved 5 kilometers, with respect to your home you moved 5 kilometers. Therefore here your home is like what? It is a origin, it is like a origin. So from there you are doing the measurement. That is called position. Is nothing but an object is always defined with respect to some reference point, which we generally refer as origin. Okay. Then next, to define the change in position, we have two physical quantity, that is called as distance and displacement. So that is called as what? Distance and displacement. So what is distance? What is displacement? Let us see. See here, what is displacement? It is the actual path traveled by the body during the course of motion is called as distance. Actual path traveled by the body during the course of motion is called as distance. The SI unit of distance is meter. The SI unit is what? Meter here. And the dimensional formula is MLT, or m raised to 0, L raised to 1, T raised to 0. So here distance is what? It is the actual path covered by the body. For example, if I take, means if you say that you are moving from your home to ground. Here, whatever the path covered by the body or the person is there, this is what? This is called as distance traveled by the body. This is called as the distance traveled. Here we say that it is the actual path. It is the actual path length covered by the body. So whatever this distance is there, this is taken as the unit of this distance is taken as it is meter, because this is nothing but the length measurement. This is nothing but the length measurement, right? So therefore we say that unit of distance is meter. It is denoted by small m. Next, displacement. What do you mean by displacement? It is the distance between the final and the initial position of the object during the course of motion is called as displacement. Means suppose here one point is there, means your home to your college or your friend home. This initial position is what? Your home, and final position is your friend home. The difference between the initial and the final position is called as displacement. The unit is also same here, like distance, it is meter, and dimensional formula is m raised to 0, L raised to 1, T raised to 0. Okay, see here, I'll give you an example to calculate the distance and displacement, how to understand this. Suppose the object is moving from A, B, C. So here you can see how many ways are there to travel from A to C. Either we can go from A to B, then from B to C. This is one path. And one more path is directly we can go from A to C. So here, whatever this A to C path is there, this we call it as displacement. A to C path, what you are traveling, that is displacement. And A to B, then B to C, this path is called as distance. Getting what is displacement and distance? So in short, we say that the shortest distance between the initial point and the final point is taken as displacement. Okay. Suppose here if it is given A to B, it is 2 meter, B to C, suppose it is 3 meter, and A to C, if it is 2.5 meter. Then what is distance? What is displacement here? Distance is taken as here. Distance is taken as distance is equal to 2 plus 3, that is equal to 5 meter. Okay, what is displacement? Displacement as I told you, it is the distance between the final and the initial point, that can be taken as 2.5 meter. You can see here the distance and displacement. Okay, one more example we can consider, that is, if a body is traveling in a circular path, here in case of a circular path, from here the body is starting and again it is coming to the same point. What is the distance? What is the displacement? See, as it is covering the circumference of the circle, distance is taken as, distance is equal to, it is 2 pi r, that is the circumference of the circle. That is the circumference of the circle is the distance traveled. What is displacement here? Displacement is taken as, it is the shortest distance between the initial point and the final point. That is nothing but 0. The distance between the initial and the final point is taken as 0. So here we can say that is displacement is 0 and distance is circumference of the circle, that is 2 pi r. here always we can say that the distance and displacement relation as distance is always greater than the displacement, or we can also say that sometimes the displacement will be zero but distance never be zero. Getting the difference between distance and displacement? Okay, so the question sometimes they will ask like, in which case this displacement will be zero? Or when a body is covering one circular path, what is the distance and displacement value? Like that we can calculate. Is it clear? Then next concept. Okay, here you can see the difference between distance and displacement. Distance is what? It is the actual path covered by the body. Okay, so here you can see the first point is definition itself. The actual path traveled by the object during the course of motion is called as distance. The actual path traveled by the body during the course of motion is called as distance. Displacement is what? It is the difference between the initial and the final position. So if you take the final position as x2, the initial position as x1, then the difference between these 2 points is called as what? Displacement. Distance is a scalar quantity, displacement is a vector quantity. So in the next slide we will see what do you mean by scalars and vector quantity. So here just I'll mention the definition. Distance is nothing but what? It is the actual path covered by the body. Okay. So here we see only the magnitude. The magnitude only we count. Magnitude in the sense the length, how much it is traveling. So that is called as scalar quantity. Vector quantity is what it is. Vector quantity is which is having both magnitude and direction. Which is having both magnitude and direction. It is called as displacement. Okay. The distance traveled by an object during the course of motion is never negative or zero, is always positive. So as I told you in the previous slide, we discussed that the distance can never be zero. It is always positive. Okay, but displacement, it may be zero, it may be positive, it may be negative based on the motion here. And the next point is the distance traveled is either equal or greater to the displacement. So always the distance traveled will be greater than the displacement. Okay, either it is equal or it is greater than that. And the magnitude of displacement is less than or equal to distance. Okay, so vice versa it is. Distance is always greater than, sometimes it is equal to displacement, but displacement is always less than or equal to the distance. Next, the displacement and is never less than magnitude of displacement. So here we can write that is greater than or equal to. And the displacement is what? It is the distance traveled during the course of motion. Then the last point is the distance depends upon the path traveled, and the displacement, the magnitude of displacement is independent of the path taken by an object during the course of motion. Okay, so this is what the difference between the, or we can also say it as comparison between the distance and displacement. Distance and displacement. Then next we have, that is, so let us discuss first what do you mean by scalar and vector quantities, then we can go for speed and velocity. See here, what do you mean by scalar quantity? The physical quantities which have only magnitude but no direction are called as what? Scalar quantities. What do you mean by scalar quantity? The quantities which are having only magnitude but there is no direction, such quantities are called as scalar quantity. Examples are mass, length, time, distance, speed, work, temperature. These are all example for scalar quantity. What do you mean by vector quantity? The quantities which have magnitude as well as direction are called vector quantities. The quantities which are having magnitude as well as direction are called as vector quantities, right? So scalar quantity which has only magnitude but no direction. Vector quantities which has both magnitude and direction are called vector quantities. right? So example is displacement, velocity, acceleration, force, momentum, torque. So these are example for vector quantities, right? Means which is having both magnitude and direction. Suppose if you say an example, you are traveling 20 kilometer today. So 20 kilometer, if you specify only 20 kilometer, it is what? Scalar quantity. If you specify you are traveling 20 kilometer towards east, this is what? Vector quantity. So when you specify the direction, those quantities are taken as vector quantities, right? Then next. Then next we are going to define what do you mean by speed and velocity. So when we discuss distance and displacement, after that we go for speed and velocity. So in your day-to-day life, you use the word the vehicle is moving fast, the vehicle is moving slow, the speed of the vehicle is more, the speed of the vehicle is less, right? So what do you mean by this is speed and velocity? We never use the term velocity. So whatever it may be, we use the term as speed only. Then here, what do you mean by speed and velocity? So when you define the distance traveled by the body, when you define the distance traveled by the body, see here, when we define the distance traveled by the body, speed is equal to distance divided by time taken. So when you define the distance traveled by the body with respect to time is called as what? Speed. It is called as speed. The distance traveled by the body to the total time taken is called as speed. Okay. So for example, if I say I am moving 10 kilometer today, so 10 kilometer in how much time you are moving? So the ratio of this distance traveled divided by time taken, it is called as speed. It is called as speed, right? So understood? So mathematically, we can write speed is equal to distance divided by time taken, or we can define it as the rate of change of distance traveled is called as speed. So I am using the term rate of change. So rate in the sense it is changing the distance we are measuring with respect to what? Time here. The distance we are measuring with respect to time, then that is called as what? Speed. That is called as speed here. The distance traveled by the body in the given interval of time is defined as speed, or the total path length traveled divided by total time taken during which the motion has taken place is called as speed. Then next, what is velocity? It is nothing but the change in position divided by the time interval. Or we can also say that displacement divided by time taken is called as velocity. So mathematically we write velocity as, that is, velocity is equal to displacement divided by time taken. Displacement divided by time taken, it is called as velocity. The rate of change of displacement is called as velocity. So the speed and velocity, we use the term v itself. Okay, so just for our understanding, we can use S and V, but usually we denote it with V only, right? So, but in our day-to-day life, whether it is a speed or velocity, we use one term only, that is speed. We never say it as its velocity. So I hope you know this one. Okay, but the physical meaning is different. Speed is distance divided by time taken. Velocity is displacement divided by time taken. Speed is a scalar quantity. Velocity is a vector quantity. And this velocity is always positive during the course of motion. Okay, sorry, that is speed is always positive during the course of motion, but velocity may be positive, negative, or zero during the course of motion. So it is greater than or equal to the magnitude of velocity. So what we say that the speed is equal, greater than or equal to the magnitude of velocity. But velocity is always less than or equal to the speed. Speed is greater than or equal to the magnitude of velocity. It is like your distance and displacement. There also we discussed, no, that is distance is greater. So similarly, speed is greater than the velocity in the magnitude. Is it clear? Then the difference between speed and velocity, if it is clear, then we can go for the next concept. In the motion of an object is along a straight line and in the same direction, the magnitude of displacement is equal to the path length. It is equal to the what? Total path length. In that case, the magnitude of average velocity is equal to the average speed. So here what they are saying, if the motion is along a straight line, then here the magnitude of displacement and distance will be same. In that case, the average velocity and average speed will also be same. But this is not always true. The average velocity tells us how fast an object has been moving over a given interval, but it does not tell us how fast it moves at a different instant of time during the interval. So this is how we can define the difference between speed and velocity, right? Then till now we discussed the unit of the, okay, unit we forgot, no? Yeah, that is in case of speed and velocity. And see, that is speed is written as how we write? Speed is taken as speed is equal to, it is distance traveled divided by time. Distance is measured in terms of, just now we saw it as meter, divided by time is second. Therefore, we can write it as meter per second. It can be written as meter per second. And dimensional formula, if I write, mass is written as m divided by. So here it is time is written as t. Therefore, it is m raised to 1. Sorry, it is not mass, it is meter, no? Okay, this is L. Therefore, it is m raised to 0, L raised to 1, t raised to minus 1. So, in some book, you may see that it is written as L raised to 1, t raised to minus 1 itself. That is what the dimensional formula for speed, and the unit is meter per second. Here, meter per second is the SI unit. Meter per second is which unit? It is SI unit. But if you take it as centimeter per second, then it is CGS unit. Okay, it is CGS unit. So we can see the CGS and the SI unit also here. Okay. So SI unit is meter, CGS unit is centimeter. Then next we can see types of speed. Types of speed, types of velocity. So in types of speed and types of velocity, we have total 4 types. We have total 4 types here. That is, the first one we take it as uniform speed. First I'll tell you speed, then we will go for velocity. So we have 4 types: uniform speed. Then next we have variable speed. This variable speed we call it as non-uniform also. Variable we call it as non-uniform also. Third one is average speed. Then the fourth one is instantaneous speed. Then we say that instantaneous speed. So what do you mean by uniform speed here? Uniform speed is nothing but it is the equal distance traveled in the equal interval of time is called as uniform speed, because we know that speed is equal to what we write? We write speed is equal to, it is distance. Speed is equal to how we write? Speed is equal to distance traveled divided by time taken. Speed is equal to distance divided by time taken. Speed, as I said, uniform speed, it means that it is equal distance traveled to the equal time interval. It is called as uniform speed. I can take an example. Suppose a body is moving from A to B point. A to B point. Suppose if I make here equal intervals, if I make here some intervals, and this interval I'll make the distance as 2 meter, 2 meter, 2, 2, 2, everywhere 2, 2 meters in a time interval of 5 seconds, 5 seconds, everywhere 5 seconds. Then here the ratio of the distance divided by time is taken as what? Speed. It is taken as speed here. That is nothing but equal distance divided by equal time taken. That is called as speed of a body, right? Getting my point? Okay. So in the each and every time interval, you can see in the given figure, in all the time interval, the distance traveled will be equal. So that is called as uniform speed. Then similarly, we can define non-uniform speed. In when you are defining non-uniform speed, here when whatever the interval you make, here the distance traveled and the time taken are not equal. Distance traveled and the time taken are not equal here. That is called as non-uniform or variable speed. Non-uniform or variable speed, right? So that is non-uniform or variable speed. Then can you give any examples? We can see here the examples for non-uniform speed is when the body is moving. So when the body is moving in a traffic, so suppose here it is a heavy traffic is there. When the vehicle is moving in this heavy traffic, what happens here between this interval? Suppose the distance is 2 meter. I'll make the interval as 2 meter. But to cover the first 2 meter, if it is taking 5 seconds. Next, suppose it is taking 4. Then next it is taking 3. Then next it is taking 8 minutes. So here, whatever the interval is there, if I make it equal, but the time is different, then it is called as what? Example for non-uniform speed. That is called as non-uniform speed. Here the distance is equal, but the time interval is not equal. Is taken as non-uniform or variable speed. Next, it comes average speed. What is average speed? So when you see the variable speed, we can go for average speed. See here, students, in case of this, in case of the above question, you can see that the distance traveled is non-uniform speed. When you are defining, we calculate the average speed. It is 2, 2 plus 2. Only this much is there, just assume that. And here it is total time taken is what? It is 1 plus 4 plus 2. So here 6 divided by 7. 6 by 7 is what? Average speed. So how we can define average speed? We can define average speed as it is the total distance traveled divided by total time taken. Total distance divided by total time taken is called as what? Average speed. So this average, it is a type of mean calculation only. Okay. So total distance divided by total time will give you the average speed. Then instantaneous speed, instant. So as the term indicates instant here, instant is nothing but that is in the given instant of time. In the given instant of time, what is the distance covered by the body is called as instantaneous speed. Means suppose if I say in the 2 seconds, what is the distance covered? So that we need to understand here by using instantaneous speed. Similarly, this velocity can also be defined as 4 types. That is uniform velocity, non-uniform velocity, average velocity, and instantaneous velocity. These are the 4 types of velocities. Here we have the definition of what? Average velocity. It is defined as change in position or displacement divided by the time interval in which displacement occurs is known as average velocity. Is known as average velocity. The SI unit of velocity is what? It is meter per second, or we take it as kilometer per hour. So the unit is kilometer per hour or meter per second. It is used in many applications. It is used in many applications here. Is it clear? That is average velocity. So here we can see one conversion factor also, where how we can convert here, because I have given you the unit. Sometimes we take it as meter per seconds, sometimes we take it as kilometer per hour. So what we can do here, we can write it as this kilometer per hour. I can convert it in terms of meter per second. How? That is, see, kilometer to meter. How many kilometer is equal to meter? That is 1000 divided by, in 1 hour, how many seconds are there? It is 60 into 60. So 60 into 60 is nothing but 3600. So I can cancel this. Then here it is 5 za, here it is 18 za. 2 5 za, 2 18 za. That is nothing but 5 divided by 18. Suppose in the question it is given like 25 kilometer per hour. Convert it in terms of meter per second. That is 25 into 5 by 18. This is what this is called as conversion factor of kilometer per hour to meter per second. Is it clear? Okay. Then here the dimensional formula is same as that of velocity. M raised to 0, L raised to 1, T raised to minus 1. So remember the conversion factor from kilometer per hour to meter per second, which will help you with the numericals. So total displacement divided by total time is called as average velocity. So average speed, I told you already, it is defined as the total path length traveled divided by total time interval during which the motion has taken place. It's called as average speed. The unit is meter per second. M, L raised to 1, T raised to minus 1. See here. So already this also we discussed instantaneous velocity or instantaneous speed. Instantaneous velocity, it is the velocity at an instant. The velocity, it is defined as, it is the limit of the average velocity as the time interval becomes infinitely small. That is, means here we take it as like dx divided by dt. That is instantaneous velocity. So small amount of time change, small distance traveled. Okay, the quantity on the right hand side of the equation, you can see it is a differential equation. It is called as differential equation. It is denoted by dx by dt. Means rate of change of position with respect to the time at that instant is called as instantaneous velocity. The SI unit is meter per second and the dimensional formula is m raised to 0, L raised to 1, T raised to minus 1. Then instantaneous speed, we know, same like your instantaneous velocity. Then in velocity, we have the other types called as relative velocity. So what is relative velocity? Let us see. See here, relative velocity. The relative velocity of one body relative velocity is nothing but it is the velocity of one body with respect to another is the time rate of change of relative position of one body with respect to the other body. Means suppose if we are defining, there are two parallel roads, the two cars are moving. Here what happens, the motion of one car we study with respect to the other. If two vehicles are moving, so which vehicle is moving fast, how you say? By comparing the velocity of them, right? Therefore we say that relative velocity of one body with respect to another body is the time rate of change of relative position of one body with respect to the other body. So how we calculate this relative velocity? We have VA minus VB. VA minus VB. That is called as relative velocity. Okay. So if you take the difference, you will get the relative velocity of that. That is next. If relative velocity is in one dimensional motion, we can treat vectors as scalars just by assigning the position positive sign to one direction and negative to the others. Here what they are saying, we can take it as a scalar quantity, relative velocity, because we know velocity is what? It is a vector quantity. But relative velocity in one dimension, we can take it as scalar. When we take the one side direction as positive, when we take the other side direction as negative, this can be taken as what? Scalar quantity. Then next, relative velocity of an object 2 with respect to 1 when both are in motion is the time rate of change of position of object 2 with respect to that of object 1. That is called as what? Relative velocity. Means here with respect to second object, the first object. With respect to the second object, the first object change we will discuss. That is called as relative velocity. So relative velocity, the formula is VA minus VB. Okay, students, in the next class, we can go for acceleration, how to define acceleration, what is the formula, then types of acceleration again, then we can go for equation of motion. Okay, so in the today's class, we have discussed that is in motion in a straight line, we study about rest and motion as it can be studied by the branch called as mechanics. So in mechanics, we have three types: statics, dynamics, kinematics. Statics at rest, kinematics without understanding the cause for motion, dynamics with understanding the cause for motion, rest when it is not changing the position, motion when it is changing the position. So in types of motion, we have one-dimensional, two-dimensional, and three-dimensional motion along with the example. And we say that rest and motion are what? Relative terms here. They are relative terms. Then what is position? When it is called as point object, then distance displacement, the difference between distance and displacement, speed and velocity, then scalar quantity, vector quantity. Then next we have the types of velocity and types of speed. So these are all points we discussed in the today's class. Okay, students. So go through the video. The chapter is simple. So numericals also little simple compared to other chapters. Okay. Thank you. In the next class, we will continue. Thank you.